All right, so 10.1, the language of hypothesis testing. It can come out as dark as I like, but I guess it's all right. So your hypothesis is a statement regarding a characteristic of one or more populations. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. Can I write on this screen? Okay. All right. So there are 3 steps in hypothesis testing. You know, if you were doing it from scratch, you will make a statement regarding the nature of the population. Kind of ran that together, but it should be nature of the population. Collect evidence, sample data to test the statement. So remember, your statements are going to be based on your sample data. Then you're going to analyze the data to assess the plausibility of the statement. All right, everybody okay? Okay, good. Okay. All right, so there are 2 parts of our hypothesis. We have our null hypothesis and our alternative hypothesis. So your null hypothesis is denoted by H and the O, H and the 0, subscript 0, and that's said as H naught. You say H naught. So it's the statement to be tested. And it's the statement of no change. Oh, I left my E off. So statement of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. The alternative hypothesis is denoted by H1. That's actually said H1. And it's a statement that we are trying to find evidence to support. All right. That is okay. Can I scroll up? All right. So there are 3 tests. See if I can get them all on one page. So there are 3 tests, 3 hypothesis tests. the two-tailed test, where your parameter is equal to some value. And notice that all of this is the same no matter what test you're doing. You have your parameter, which is going to be the same. It's going to be equal to some value, and that some value is going to be the same. But what is going to be different is your symbol right here. And there will be keywords or key phrases that will let us know which symbol to use. So if we end up in equal, if we end up, and you'll see those symbols in the example, but if we end up using the not equal to symbol, it will be two-tailed. Less than symbol gives us left tail, and then the greater than symbol gives us a right tail. And both the left tail and right tail tests are considered one tail tests. All right, any questions? Any questions? All right. So here's our first example. We want to determine the null and alternative hypothesis. State whether the test is two-tailed, left-tailed, or right-tailed. So the Medco pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. I almost thought I was finished. Is more than 2%. So I'll give you guys a chance to write it down. All right, so we want to look at how we're going to set up our null hypothesis and our alternative hypothesis. So when we're looking at look at what we're going to use as far as our parameter is concerned, it says that 2% of the children taking the competing antibiotics. And then when we look down here, we want to, it says taking new antibiotics who experience headaches as a side effect is more than. So we're just looking at the percentage. And then the other key phrase is more than. So when we look at setting up our hypothesis testing, Our parameter is just P for the percent. All right. And 2, that 0.02 comes from the 2%. Convert that to a decimal. So if you're dealing with any percentage, you always want to convert that to a decimal. Once again, once you establish your parameter, which was P, and the percentage, which was 2, that part is going to be established. You always start off your null hypothesis with equal. If you were to go back, all of these have equal. But then it's about what symbol you're going to use. And the symbol we're going to use right here is more than because, it's greater than because it says more than. So that's how we look at setting up our hypothesis testing. In this case, we use P for the parameter. If you decide to use P here, then you use P here. And then 2% was what we're comparing. If you use 2% here, you use 2% right here. This is always going to be equal in your null hypothesis. So then what determines the symbol you would use in your alternative hypothesis is the wording. And we had more than, so that's why we use the greater than symbol. And because we use the greater than symbol, that means it's going to be right tail. All right, questions on that? All right, the next one. The blue book price of a used 3-year-old Chevy Corvette is $86,000, well, $86,012. Grant wonders if the mean price of a used 3-year-old Chevy Corvette in Miami is different from $86,012. All right, so here, keyword here, or the keyword that we're looking to set up the symbol for our parameter is the mean. So the mean price of this Chevy, and so that's why we use the symbol for the mean here, Greek letter mu, and then says different from, before I go to different, the number that we're looking at that we're going to use in our parameter or in our establishment of our null hypothesis is the 86,012. So that's why we have this. So if I use mean right here, I need to use the mean right here. So if I use mu, I need to use mu right there. Then if I'm going to use 8612 here, I need to use 8612 here. Once again, this is always equal for your null hypothesis. Then what is the keyword that's going to dictate this symbol right here is different. So in other words, it could be greater than or less than. We don't know which. We want to know if it's going to be different. So that's why we use the not equal symbol. And if it's not equal, that means it's going to be two-tailed. And that means we're talking about to the right or to the left, less than or greater than. All right. Questions? Any questions? All right, last one like this. C, the standard deviation of the contents of a 64-ounce bottle of detergent using an old filling machine is 0.23 ounces. The manufacturer wants to know if a new filling machine has less variability. All right. So our parameter is standard deviation. So that's why we're using sigma. And once again, whatever I use here, I need to use right here. This is always going to be equal. 0.23 comes from right here. And key phrase is less. So look at less than. And because it's less than, that means it's left tail. Any questions? All right. And this is the last thing out of this section. And at the 4 outcomes when we're looking at when we're doing hypothesis testing. So first one, we reject the null hypothesis when the alternative hypothesis is true. So that's a correct conclusion. You do not reject the null hypothesis when the null hypothesis is true. So this is correct conclusion as well. So looking at the first one, you do want to reject the null hypothesis if you find out that the alternative hypothesis is true, or you have enough evidence that says that the alternative hypothesis is true. You do not want to reject the null hypothesis when you know that the null hypothesis is true, right? So now the third one is an error. If you reject the null hypothesis when the null hypothesis is true, that's considered a type 1 error. If you do not reject the null hypothesis when the alternative hypothesis is true, it's considered a type 2 error. So notice that your decisions are based on the null hypothesis, rejecting or not rejecting the null hypothesis. And that's how you would be framing your conclusions. And we'll get to our conclusion wording in 10.2. All right. Then we have our level of significance. It's noted by alpha. It's Greek letter alpha. and it's the probability of making a type 1 error. And what I could have written, and I'll write this in a second, but you guys a chance to write it down. All right, anybody still copying before we go to the next page? This is me writing a note to myself. So you want to copy that. And then here I wanted to state, just in case my math lab asks. No, I don't want to do that. Yeah, that's fine. I just mentioned this. So alpha, like I mentioned before, is a probability of making a type 1 error. Beta, that's what this is, Greek letter beta. It's a probability of making a type 2 error. All right, so the probability of making a type 1 error is chosen by the researcher before the sample data are collected. So we're talking about alpha, and that's why we had the definition of alpha initially. So the choice of the level of significance, alpha, we're talking about alpha, depends on the consequences of making a type 1 error. Chance for far right. All right. And talk about error. Saying hi, alpha. All right, so if the consequences are severe, alpha should be small. I should put a comma right there. If the consequences, and then we're talking about alpha being 0.01, but if the consequences are not severe, a higher alpha can be chosen, 0.05 or 0.1. All right, so one last thing. All right. So the level of significance is not always set. All right. So level of significance is not always set at alpha being 0.01. Remember, that was the smallest option. So you would think that you want to decrease your chance of making a type 1 error to the, smallest probability possible. But when you reduce alpha, that increases the probability of beta. Remember, beta is a type 2 error. So when you reduce the chance of getting a type 1 error, you actually increase the chance of getting a type 2 error. So for some reason, I don't say for some reason, they don't really get into the reason. There is a reason. We just don't, we're not going to get into the reason. Not necessary for what we want to do. So they have an inverse relationship, and as one goes up, the other one goes down. So that's what that means for that. As one goes up, the other one goes down. So you have to pretty much count the cost. Which one do you care the most about, having a type 1 error or type 2 error? And that's what they were mentioning about the consequences. You weigh the consequences of having a type 1 error. And all of these things would be done, for somebody doing this research from scratch. Doing it from scratch, you would establish the consequences or count the costs on which one is more important for you to possibly have. And so, of course, when we doing these, they would give you your level of significance, so you wouldn't choose it. So, just giving you the background as to how you would do this if you were starting from scratch. All right, questions. All right, so that's it for 10.1. All right, so we can say 10.2 for next class, and then we should be good to go. Monday we will not have class. I have a funeral to go to, so next class would actually be on Wednesday, and we'll go from there. Questions? Any questions, concerns, comments? And I'll probably shoot an email out to remind you guys. Questions before we close out today, going to the weekend. Very good, very straight. All right, so you guys have a good one. Be safe, and I will see you on Wednesday.